Computational model. Introduction. Purpose. Introduce the concept of computational models and their importance in solving real-world problems in computer science. Definition. Computational models are mathematical frameworks that describe how a system operates and processes information. Importance. They are essential for designing algorithms, understanding system behavior, and improving decision-making processes.
So for the outline of the models, first is the Finite State Machine, next Turing Machine, next Markov Model, next Neural Network Model, and lastly Genetic Algorithm.
1. Finite State Machine, FSM. Definition. An FSM is a computational model that represents a system using a finite number of states and transitions between those states based on input. Components. States, distinct configurations of the system. Alphabet, set of inputs that trigger transitions. Transitions, rules that define state changes. Initial state, starting point of the system. Final state, accepting or halting state. Types. Deterministic FSM, one transition per input. Non-deterministic FSM, multiple possible transitions for the same input.
Now for the applications. First, traffic light control. Traffic lights operate using a deterministic finite state machine to control the sequence of light changes. Each state corresponds to a specific light color, and transitions between states are triggered by a timer or sensor input. Another one is pattern recognition. Finite state machines are used in pattern recognition tasks such as text or speech recognition. So for example, a spell checker can be modeled as an FSM or finite state machine where each state represents a letter, and transitions occur when valid sequence of letters are detected. So for the real-world application of finite state machine. First, regular expressions. Regular expressions are implemented using finite state machines. When processing a regex, the FSM starts in an initial state and transitions through states based on input characters. For example, the regex A times B will match strings like B, AB, AAB, and etc. as the finite state machine transitions through states based on each input character. And another one is elevator control system. So in an elevator operates based on an FSM where each floor represents a state. When a button is pressed, the FSM processes the request and transitions the elevator to the requested floor.
2. Turing Machine. Definition. A Turing machine is a theoretical model that manipulates symbols on a tape according to a set of rules, representing a more powerful computational model. Components. Tape, infinite sequence of cells for data storage. Head, reads and writes symbols on the tape. State register, stores the current state. Transition function, defines the next state based on the current state and symbol. Working principle. The machine reads a symbol, processes it based on the state and transition function, and moves the head left or right.
Real-world applications of Turing-complete models. Search engines. Search engines rely on complex algorithms to index and rank web pages. Every search query runs through a computation model that determines the most relevant results. These systems use Turing-complete models to process large-scale data and execute ranking logic and return search results in milliseconds. These computations involve crawling web pages, indexing content, and executing query matching functions, tasks that require a system capable of running any computational function, just like a Turing machine. The next application is the music recommendation systems. Spotify's recommendation system analyzes listening history, user preferences, and song attributes to suggest music. The system uses machine learning algorithms, which are fundamentally Turing-complete, to predict what a user might enjoy based on behavioral patterns and collaborative filtering. These systems analyze user behavior, such as song histories, skips, and likes, to predict what a music user might enjoy. By leveraging machine learning, which operates on Turing complete principles, these platforms continuously refine their recommendation based on new data.
3. Markov Model. Definition. A Markov model describes a system that undergoes transitions from one state to another based on probabilistic rules. Types. Markov chain, no hidden states. Hidden Markov model, HMM, states are hidden from the observer. Components. States, possible configurations of the system. Transition probability, probability of moving from one state to another. Observation probability, probability of observing a particular output.
Application. In speech recognition, hidden Markov models were historically essential modeling the likelihood of sequence from speech signals. Though deep learning now leads, hidden Markov models establish crucial foundational principles. So for stock market prediction, Markov models analyze shift between market states, estimating the likelihood of transition to identify potential trends. However, due to the market complexity, they should supplement, not replace, other analytic tools and should not be the sole of basis for investment decisions. So, in real-life example of Markov model, weather prediction using Markov model. Markov model helps predict weather by modeling transition between states like sunny, rainy, and cloudy. The probability of moving from one state to another, example, a 30% of rain after a sunny day, help estimate future weather patterns since the model relies on only on the current state. It is effective for short-term forecasting and is widely used in meteorology.
4. Neural network model. Definition. A neural network is a computational model inspired by the human brain, consisting of layers of interconnected nodes, neurons. Structure. Input layer receives raw data. Hidden layer processes and transforms data. Output layer generates the final result. Types. Feed-forward neural network, simple one-directional flow. Convolutional neural network, CNN, image processing. Recurrent neural network, RNN, time series and sequential data. Training and backpropagation. Uses backpropagation to adjust weights based on error rate.
This is the application of neural networks. The first one is the image and speech recognition. It is used to facial recognition or face ID and voice assistants, just like Siri and Alexa. The second one is autonomous vehicles. It helps for self-driving cars, detect obstacles, and making decisions. And next is the chatbots and AI assistants. It enables human-like conversation in AI-driven applications like customer service bots.
5. Genetic algorithm. Definition. A genetic algorithm is an optimization model inspired by natural selection and evolution. Components. Chromosome, solution representation. Population, set of possible solutions. Fitness function, measures solution quality. Crossover, combines two solutions. Mutation, introduces small changes. Working process. Generate initial population. Evaluate fitness. Select best candidates. Apply crossover and mutation. Repeat until convergence.
So for the application of a genetic algorithm, first is the bioinformatics and drug design used in sequencing, protein structure prediction, and medical research. Next is the machine learning and AI used for optimizing neural network and feature selection. Last is the optimization and industrial optimization that enhances manufacturing processes, scheduling, and production planning. So for the real life example, it's the airline flight scheduling using genetic algorithm, and the objective is
to optimize flight schedules for efficiency and cost reduction. So, genetic algorithm process application in flight scheduling is when a chromosome represents a set of flight schedules. Next is the fitness function that evaluates efficiency and operational cost. Next is the crossover combines successful schedules for improvement. Next is the mutation, adjust schedules for new constraints such as weather and demand. So for the results, it optimizes flight routes. Next is reduce fuel consumption. Next is lower operational costs. And last is improve passenger satisfaction.
So here are our references for our models. Thank you for watching.